philosophy is based on sound science and free from the outdated dogmas of the 20th century.
Hi, this is Gabe Ignetti.
And this is Rick Maltese.
And this is the Echo Modernist Podcast. On June 26, 2016, a group of 21 academic and private energy researchers led by Christopher Clack produced a paper in the prestigious Proceedings of the National Academy of Science Journal, which refutes the famous 2015 study headed by one Mark Jacobson from Stanford University concerning the viability of 100% wind, water, and solar-powered economy. We have with us today Mike Conley and Tim Maloney, who have produced a work entitled Roadmap to Nowhere, The Myth of Powering the Nation with Renewable Energy, which is a commentary on Mark Jacobson's work and which is free for download online. We also have from the Netherlands, Thies Beckers. Thies is the author of 3 books, including his last book, The Non-Solutions Project. He also goes by the name of the Nuclear Humanist, which is the title of his popular science show on YouTube. Gentlemen, welcome to the show. Your basic thesis is that road is really a dead end. Why don't you start out by making your case?
We think that the plan won't work because it's too complicated. The renewable sources are not reliable. There's not enough backup. We don't have storage in place, and the plan is a dud, in our opinion.
Yeah, this is Mike. We found it very presumptuous of Jacobson that he's trying to get the entire country running on nothing but renewables. In other words, with a fuel-free system, backed up by other renewables and whatever existing hydro storage and dams that we have. And if you really dig into his numbers, the amount of money and land, resources, labor, raw material to build what he has in mind is just astronomically ridiculous. It probably could work in theory or in principle, but the problem with that is we would have to build a lion's share of it to see if it does work. You're not really going to know if it's going to work as intended until most of it is built. And by then, you've invested all that time and material. With everything you invested, you almost have to make it work, which means you'd have to back it up with whatever storage or fueled backup is necessary to make all the pieces work. We found it ridiculous to propose that to the American public. Let's build all this stuff and see if it works. We're talking about $15 trillion worth of construction.
Bare bones.
Yes, that's without backup and storage. So he says, let's take $15 trillion and build all this stuff and connect it all together, and I bet it'll work. And we're like, well, what if it doesn't? Then you got to spend more money on backup and storage. And now you're up to like $20 trillion. You can do an entire nuclear grid for like between 3 and 7 trillion. So why even bother to go down that road?
When it comes to the overbuild issue, besides backup and storage, what USA is doing right now is operating with 150% overbuild generating capacity just to run the electric grid, not the whole primary energy of the society. And this plan says we need almost zero overbuild to run not just the present electric grid, but the whole society. The idea is dumbfounding.
Overbuild meaning if America needs, for example, 500 gigawatts of power, you would build the capacity of generating 100 gigawatts, so you have 100% overbuild. That's just a thumbnail sketch. He's saying build a fuel-free system with 4.38% overbuild. We have a fueled system, and our overbuild is actually, I think, 150% in America.
Okay. Thies, you have anything to say?
Well, first of all, I think that Mike and Tim did a really good job. I read their book. I think it's second to none.
Oh, thank you.
I love your footnotes, by the way.
Oh, thank you.
Oh, thanks.
That's where he gets into all the nitty-gritty, and he makes sure that it's able to be followed.
Yeah, that's very important.
There's nothing more important than making people capable of checking the facts.
Yeah, That's
Even if they don't do it, they want to know that they could do it.
Yes. Jacobson relies on a 15 times increase of hydro capacity in the US. So it currently stands at 85 gigawatts approximately. And he wants to expand up to 1,300 gigawatts capacity, which is impossible. The Department of Energy says so. And aside from that, my biggest beef with it, apart from all the mathematical issues, is the fact that it has gained so much traction and right now serves as the reason for these people to believe that it actually can be done. It is obvious that it's very unlikely that it can be done. So we are betting on the wrong horse.
What happens is the public has been told by Jacobson repeatedly, we don't need nuclear. And then the California state legislature being lobbied by his acolytes, we don't need nuclear, we don't need nuclear. And so now they're shutting down Diablo Canyon and replacing it with natural gas. And as everybody knows, natural gas is a finite resource. And the natural gas industry has already predicted that we're going to run out by mid-century. We're going to run out even faster if we shut down reactors or replace them with natural gas. So what do you do when the natural gas runs out and your nuclear industry is shut down? You can't revive an industry that big in like a couple of months. And so shutting down an entire industry on the presumption that you don't need it because you only need natural gas for a while until all this wind and solar starts backing itself up, and then tra-la, we won't even need the natural gas. He's really expecting the United States to invest that much money and that much time to see if this notion will play out. But that's where the California state legislature has bought into. You can't even talk to those people about nuclear. They just roll their eyes. Oh, we don't need nuclear. Why? Because Jacobson said so. Well, how the hell do you know he knows what he's talking about? He's from Stanford.
No, it's only the buzzword, renewable. That's all they need. It's renewable and sustainable.
That's what's happening, is you're getting a lot of uneducated people that are being whipped around by opinions of so-called experts. And they're just going, well, yeah, this authority says that, so I'll vote for that. And then all of a sudden you don't have any reactors in the state, and good luck on that. You know, we're going to have blackouts.
I don't know if you guys remember, any of you, but Jacobson, if I recall, said a lot of crazy things about nuclear power.
Sure. Yeah, one of the big things he said was because there were 2 nuclear weapons set off in 1945, you can therefore predict there will be X amount of nuclear weapon explosions for X amount of years of nuclear energy. Because the nuclear industry is in existence and there was 2 nuclear weapons set off against civilian populations in X amount of years, therefore, that will occur, and it will put a lot of carbon in the air because of all the fires of nuking a city. Therefore, nuclear energy really does have a lot of carbon connected to it because this will inevitably happen. That is actually what he is saying, and people are buying it hook, line, and sinker.
Well, they don't realize he's saying that until somebody like James Conka comes along and points out that Jacobson's argument depends on a nuclear war every 10 years.
Or 30 years, but who's counting? Because, according to him, the existence of nuclear energy will inevitably mean the existence of nuclear weapons, which will inevitably mean that people would use them, which will mean carbon in the air. Therefore, we don't need nuclear. So if we shut down the nuclear power industry, the nuclear weapon industry will magically evaporate.
Well, actually, if we continue with the megatons to megawatts program, we will eventually eat up all nuclear weapons, or at least a great portion of it.
Exactly.
Christopher Clack and the National Academy of Sciences is in court with Mark Jacobson right now. It is currently under arbitration. What is your assessment of all this?
Well, what our opinion is on that, I think he made a fool out of himself because he is trying to adjudicate the veracity or lack thereof of science by appealing to a court. And I think it was Oliver Wendell Holmes or somebody like that pointed out A court is not the forum to decide the veracity of science. I am actually glad that he did this because I think it's going to draw a lot of attention to his plan and to him. And I would be utterly astonished if it went in his favor because it's so egregiously ridiculous that a scientist would try to resort to the courts because somebody used his calculations to show the deficiency of his own plan. Yeah, so it's like Trump suing somebody because they report what he says. He's trying to sue somebody for reporting on what he said by saying it's defaming him. Well, if it's defaming you by reporting on what you said, maybe you better think twice about what the hell you say.
I gotta laugh.
Let me add that, and this is something somebody else noted, I can't recall who. Basically, what Jacobson is doing right now is mirroring what he thinks is being done to him. He is attacking someone personally because Clack doesn't have the full support of a university anymore. Right. And I'm glad that PNAS has become a party in this whole matter too, because somebody should throw themselves in front of Jacobson's ire and make sure that Clack can remain untarnished, unharmed, and can remain doing what is scientifically valid and honest.
I expect PNAS to come to Clack's defense and pay any legal expenses incurred by Clack.
Let's answer something. Proceedings of the National Academy of Science. I just wanted to straighten that out for the audience.
It's the trade magazine that published Jacobson's paper and Clack's paper.
Well, even if Mark Jacobson's plans were to be pursued, I have to wonder if the environmental movement would go along with all of this as the rubber hits the road. I know the Sierra Club has come out against plans to put down trunk lines to draw electricity from a solar farm in California years ago. Just what kind of ecological price must be paid to put such a system in place?
Well, a solar PV farm makes the land utterly useless as wildlife habitat or agriculture. So the land is completely sacrificed, unlike a wind farm where the space between the windmills can still be farmed for crops. So yeah, large solar farms are utterly disruptive to the
ecology and habitat. The land area of solar farms that he is speccing for his plan would occupy land equivalent to Maryland, Rhode Island, and Connecticut. What is it, Tim, about 20, 30,000 square miles?
It might be 20 or 30,000 square kilometers, that's about right.
Oh, kilometers, okay, yeah. And so you take a look at the footprint of that, but it isn't just a footprint of the land occupied, it's also the ecological footprint of the amount of mining and recycling and the energy it takes to fabricate that equipment. And then the human resources it takes to fabricate, install, and recycle and refurbish that equipment. You're dealing with 18 billion square meters of panel and 498,000 5-megawatt wind turbines, each of which are about 35 stories high, 156,000 of which are at open sea out offshore, which have to be refurbished offshore. And if you take a look at the refurbishment rate of the wind turbines, the refurbishment rate at the most optimistic would be about 50 or 60 major overhauls initiated every single day in America. At the outside, about 80 complete major overhauls, along with the installation and recycling of 1.23 million square meters of panel. And that is just to tread water. That's just to keep his vision functioning. And so the amount of ecological footprint of all that industry and busyness and mining and recycling and fabrication and installation and tromping around, et cetera, versus 6,000 small modular reactors, each of which is the size of a city bus, that could be built by probably 2 or 3 factories that would require about less than 3 swap outs per day with 6,000 of them installed. That's your ecological footprint.
And regarding your comment about mining and material, Mike, do note that in Roadmap to Nowhere, we do the calculations to compare the amount of steel and concrete needed for the so-called renewables technologies compared to Generation 3 plus nuclear. And of course, I can't remember the exact factors, but they're substantial. I think it's 8-to-1 in terms of steel consumption.
Well, that is if you figure out the peak capacity of the wind and solar, but the average capacity of the wind and solar is actually 24-to-1. And what that means is if you take X amount of steel and concrete to build Y amount of reactors, you're going to have to do 24 times that steel and concrete to get the same average capacity of energy generation from wind and solar. 24 times.
Concrete is even worse, as I recall.
And so you look at the amount of mining and then the energy for all the refining of that steel. So it isn't just digging it out of the ground, it's the energy you have to expend to fabricate that steel. It is, in theory, economically feasible if the United States guts its military budget and its social spending budget. This could, in theory, actually be done, but to do it, you would have to get the United States populace to agree to give up 80% of its military budget for 35 years.
Which is calculated and graphed in Roadmap to Nowhere. That calculation has been done and displayed for our readers.
Exactly.
Let me interject something, and you could tell me if I'm wrong about this, that both steel and cement require high heat, which means, I believe, coker plants, which in other words, we're talking about the only way you could produce steel and cement is with fossil fuels and a lot of it. Am I right about that?
Well, as things exist right now, yeah.
You can use nuclear. You can use nuclear and do it electrically, and you can also use molten salt reactors, which have a exit port temperature of like 750 degrees Celsius, to use that as process heat to make the steel and to make the concrete. So actually, you don't need fossil fuel to make concrete and steel. You can use nuclear energy.
There's one problem with that, and that is that you need to coax the steel, which requires free carbon atoms. You always need some form of carbon input, otherwise you have iron.
Yeah, well, carbon input, but not fossil fuel burning to get that carbon input.
That's true, that's true.
So you use nuclear energy to provide the power and the heat, and then you got to dig some carbon out of the ground to toss it into the iron to turn it into steel. Well, that's just your chemistry magic happening.
Of course, this is all in the future.
Yeah. We are only proposing an all-nuclear grid because Jacobson is proposing an all-renewables grid. In reality, you're never going to have an all-nuclear grid because, for one thing, there's all this wind and solar being built right now. We're not going to go around and burn all that if we switch over to nuclear. I mean, it's obviously going to stay there, and we're going to use whatever's usable of it. As a consequence, the real world will dictate that we will have a mixed grid. We simply counterposed his, what we think, highly hypothetical idea with a hypothetical one of our own, and the hypothetical one of our own is actually feasible if you were to choose to have a monoculture grid.
Oh, by the way, cement that can be done free from fossil fuels, but it still has carbon emissions.
Oh, sure it does.
Because you're heating up limestone or calcium carbonate in order to disassociate the carbon dioxide and get calcium oxide.
But there's also different formulations for like what
This is
Portland
cement.
Yeah, they have a concrete now that I don't know if it's in development or already in existence, but it uses the CO2 and seawater.
But yeah, I mean, there are other concrete formulations. And so I think the thing that has to be looked at is not the specific recipe, but the energy used to cook it up.
Yeah.
But when you take a look at a hypothetical all-nuclear grid, 6,000 small modular reactors, each one about the size of a city bus that can be transported by rail or ship and installed with the 7-year runtime. And when it wears down, you take it back to the factory. If it melts down, it doesn't melt through, and the reactor vessel becomes the reactor's own sarcophagus.
Yeah.
And so basically it's a nuclear battery you're not going to have a meltdown, melt-through problem you had in Fukushima. Remember in Ghostbusters where they caught the ghost and there's this little box at the end of a cable that Bill Murray is holding on to and is smoking? That's like the melted down small modular reactor. It's in the box. Take it back to the factory. You see what I'm saying?
Yeah.
Yeah, and so you take a look at 6,000 small modular reactors. That can be built by a couple of factories of the size that maybe turn out Learjets. With a 7-year runtime of each reactor on average, you're looking at 6,000 reactors at 2.3 swap outs per day. So somewhere in the country, 2 to 3 reactors are being swapped out for fresh ones and taken back to the factory. That's the extent of the industrial busyness of an all-nuclear grid versus the industrial busyness of 1.23 million square meters of panel that have to be swapped out every day and recycled, and 50 to 80 full-blown overhauls of wind turbines that are the size of a 35-story building, 156,000 of which are at sea,
Right.
open water. So look at the industrial busyness of the two, and that alone should scotch the idea of an all-renewables grid.
What I like about ecomodernism is that the quality of life is taken into consideration. We do not sacrifice the environment or our standard of living. Does Jacobson factor in the quality of life in his scheme?
Yes, he does, but it's really interesting is he goes on, oh, well, you know, if we build this, it'll pay for itself because of all the healthcare savings because we won't get people sick from fossil fuel. And people go, yeah, we don't need nuclear. It's like, wait a minute, dude. If you do the same thing with nuclear energy, you're going to have the same reduction in healthcare costs for the same reason. You will have a fossil fuel free source of energy for the country or a carbon free energy generation. So it's a wash. So the monetary advantage that he cites can be replicated with an all nuclear grid. So basically it's like, what's your point, Jacobson?
Yeah.
About the modular reactors?
It's just kind of like he's selling a car to you and he's saying, dude, our car comes with tires.
Yeah, that's true. That's absolutely true.
Tires in the form of better healthcare.
Present nuclear reactors, they having a lot of trouble because the skill sets are not there. And probably, I don't know if we have enough technicians. Now, with the modular reactors being like factory produced and all of that, is that problem solved?
I don't know that much about it. As my understanding, and I think, Tim, you'll concur with me, is a factory built basically a nuclear battery. It's like, how much technology do you need to put a battery in a flashlight? If it's a self-contained thing that generates power, where literally it is delivered and installed and is plugged into your generation system, and the guy tips his hat, grabs a cup of coffee, and hits the road. That's it. And so what does it take to run a facility that has a nuclear battery that you are drawing power out of?
See, I'm no expert on this, but my understanding is that these things are essentially self-operating. That you really don't need a human reactor operator there. Of course, we'll have one, but he's superfluous.
Here's the thing. If you take a look at what we call it energy feudalism, and we use that because back in the old days, before the invention of mechanization, you had 20 people growing enough food for 22 people. That's the way human history has evolved prior to, steam and coal. And the last 2 people were the nobility, and that was a feudal system. And the amount of labor it would take to fabricate, install, maintain, recycle. Jacobson's renewable grid, you're looking at hundreds of thousands of people to fabricate, install, recycle all this equipment. Our view is that you should have just a tiny, tiny sliver of the American workforce involved in generating energy for the country, similar to what we have a very tiny sliver of our workforce that is growing food for the country. And so we don't think that it's an advantageous sales point to say, oh, with a renewable grid, we'll have all this work for all these people. Well, so we have millions of people working to keep the lights on. It's make work. Rather than a small, skilled, specialized group of maybe amount to 5,000 or 10,000 people scattered throughout the country that are basically babysitting nuclear batteries, and then another couple of factories to make them and to refit them and clean them out, refuel them, or bury them. So one of the sales points of renewables has been the jobs that it would create. And I would rather see us rebuild 30,000 bridges that need rebuilding than build 498,000 wind turbines that need overhaul.
And make work appeals in the short term because of the job opportunities, but long term, not a viable solution.
You give an estimate of the cost of an all-nuclear grid as being somewhere between $3 and $7 trillion in comparison. What do you base that on?
Oh, we just made that up. No.
The $3 trillion comes from calculating the number of small modular reactors using a price per average watt derived from the Thorcon company. We think it's the Thorcon company. It's somebody who participated in one of these studies, what their manufacturing cost will be. That's how we derive the low end of that range, the $3 trillion. The $6.7 trillion, rounded to $7 trillion, comes from referring to the KEPCO, Korea Electric Power Company, large project in the United Arab Emirates, which is now about 1/4 finished, and using their estimated construction cost per average watt basis.
Well, it's a proven construction cost. They finished the first reactor, and it cost $440 a watt.
And it's the APR, which the Koreans in Korea themselves can build for a lot less money.
That's $250 a watt. And so we'll leave it to everybody else to figure out why it costs more in the United Arab Emirates. But anyway, aside from that, you got to understand that the molten salt reactor and the small modular reactor price estimates are estimates based on the companies that intend to build them, but they have not yet been built. So they are speculative prices. The 6.7 trillion, however, is a proven price of a reactor that is a standardized design, meaning it's cookie cutter. Every reactor ever built in the United States up to this point has been a custom design. It's similar to building a prototype Lamborghini up on blocks, because every innovation we had along the way was put into the new project. So when screw that, we got a good enough design. So they're building an old school Generation 3 1960s technology cookie cutter reactor for $4.40 a watt. The Gen 4 people theorize that their reactors will be down to $2 a watt. But even if they are at $4.40 a watt, it still beats the pants off of Jacobson's prices and grid by a long shot. If the Gen 4 stuff doesn't work out, we can do with existing 1960s old school pressurized water reactor technology, we can run the entire country for under $7 trillion on a footprint that would equal 1/2 of Long Island.
So how does the price of nuclear compare to the price of coal?
So the nuclear would be a little more expensive, but there wouldn't be any pollution in the air.
Nuclear a little less expensive, Mike.
Coal plant is about $350 for an MSR, a molten salt reactor Gen 4 or a small modular reactor Gen 4. If they are built for the predicted price, they could be as low as $2 a watt.
Got it.
And now here's the thing about that $2 a watt. You got to understand, Thorcon has stuck their neck out more than once by saying that that is the price that they will have.
Right.
We'll see how that turns out. But even if it's double that, even if it's triple that, it's still much more favorable than an all renewables grid for these various and other sundry factors, completely aside from the fact that a renewables grid is utterly dependent on favorable, predictable weather.
35 years from now.
I think that they should be able to predict the weather for 100 years. If you carve out a wind or solar farm and spend all that money to place it there, you better be assured that it's going to be productive, or that land is going to be productive for that purpose for far more than 30 or 40 years. And another thing on that point, Jacobson's paper at the time it was written was using a 134 watt sunflower panel. We calculated his stuff with a 188 watt sunpower panel, the newest one on the market. So we used a better panel than they use for their calculations, and their calculations still don't work.
What kind of issues occur with renewables compared to an all-nuclear grid?
Well, here's the thing. In an industrial PV farm, we presumed, and I think correctly, that there's going to be little robots that roll up and down the arrays that are cleaning the panels. I mean, it'd be insane to have a 1 million panel farm in the middle of nowhere with no automated cleaning equipment, because the only alternative is to hire a bunch of squeegee people.
Yeah.
No, seriously. I mean, so, that could be a jobs program, but if I was running a solar farm, it's like, how do you clean this truck? Okay, you get this truck, and this truck does this, you drive up and down it, fine. And if it's snowing, drive the truck up and down and whisk off the snow, fine. So I'm sure that's all in hand, and we didn't really factor that in. What we factored in is the main maintenance is how long does the panel last?
Right.
And what does it cost to replace the panel, as distinct from replacing the foundation and the racks, because you just pull the panel off and put on a new panel, and so the replacement cost isn't nearly as much. We go into those prices in roadmap.
It's kind of interesting and necessary to point out that you have to assume a particular lifespan when you're making these comparisons, and our assumption is 60 years lifespan for a Generation 3 or Generation 4 reactor.
Right. And so we compared it with the 60-year span of an all-renewables grid, and that's where we get into how many swap-outs and how many overhauls. Swap-outs meaning you take out a worn-out panel and put in a new one, then you recycle the panel, and also probably have to fabricate the panel, because one thing we point out in the book is if we were to do Jacobson's plan, the amount of solar panels that we would need on a daily basis just to maintain our solar fields is equivalent to China's total solar panel fabrication capacity right now. So we would have to either be their only customer or we would have to be our own China just to tread water.
I've heard that nuclear also has costs of maintenance. Someone was telling me that about halfway through the life of a nuclear plant that you literally have to overhaul it. I don't know if that's true.
Well, with a small modular reactor, you just take it back to the factory. Imagine a sealed steel vessel about the size of a city bus with walls about 5 inches thick that a missile would literally bounce off of. And it's all inside there, and there's no maintenance on the job. If it malfunctions, you call up the company, they come and get it and give you another one. So it is literally plug and play.
Yeah.
And so what you need is you just need the operators that are running an electrical power plant. And basically their power fabrication thing is a black box, which happens to be a nuclear black box rather than a coal-fired black box. Because the steam generator and the transmission is all the same. It's just you got gizmo A or gizmo B that's generating heat to make the electricity, et cetera. So what we look at is the amount of equipment or labor or whatever for maintaining the grid, and it comes down to the fabrication, installation, and recycling of how many panels, and the installation and then major overhaul of how many wind turbines. And we checked with 2 wind turbine overhaul companies. That's all they do, is they refurbish wind turbines. And they gave us the estimates that it's about 10% of the original installation cost. And it's obviously more for offshore in open sea, but we even gave Jacobson the advantage of not tacking on an extra charge for the $156,000 that have to be overhauled in open sea. Because an open sea turbine, you take a ship out there, you take the turbine down, or you send people up and you overhaul it at sea.
Yeah. And think about it. These things are mechanical boxes. So that means that there's...
It's easier, of course, to put the new propellers on and take the old ones back to shore to refurbish them, to resurface them, to sand them down, or to patch the dings, etc. So you go out there with a ship with 3 propellers, you swap out the propellers, you send a crew up there to rebuild the turbine up in the housing for like a week or whatever. The extra at-sea cost we didn't factor in.
And not to mention the gearbox fluids that need to be changed.
All that stuff, yeah. It's a major, we just call it a major overhaul. Simply
Yeah.
like you take your car in and you just redo the engine. And generally what that comes down to is gears and bushings and bearings and seals. Transmission, right, exactly. It's the same thing with a wind turbine. It's a piece of mechanical equipment that is being used in a harsh marine environment. Things wear down.
Besides, I wonder how long you can maintain, for instance, the column that supports the whole thing, that keeps it up like 80 million.
Well, I just presume that they would be on the case and paint it really good, and part of that might be a maintenance painting or whatever, but I wouldn't be surprised if those columns could last 60 or 80 years with proper maintenance.
There's a thing that you're overlooking there. It's not necessarily, for instance, rust or anything like that, but material stress. If these wind turbines are subjected to a lot of high-speed winds, for instance, and at some point you can get fracture points.
Oh, fatigue, like metal fatigue, like
yes, exactly.
wings on an old airplane.
Yeah.
Yeah, we didn't even look into that. That's another freebie that we gave Jacobson. We didn't look into that.
Yeah.
But the thing is you could sort of say the same thing about a reactor, but the thing is a small modular reactor, after 7 years, is taken back to the factory, and it's either refurbished and refueled and cleaned, or they bury it as its own sarcophagus and ship you a new one.
Mm-hmm.
And so all that factory busyness can take place at a couple of factories around the country, right? Once it's built, you're only talking about 2 to 3 reactors that have to be addressed per day, and they're only about the size of a city bus. And so that's quite feasible for a factory, like 3 factories across the country to take care of. That averages 1 reactor a day. And it's basically about as complicated as building a Learjet.
Yeah. Absolutely. Well, it's a lot less.
Probably a lot less.
Yeah, a lot less.
The point being is if you can have a factory crank out a Learjet in a month, why can't you have a factory crank out something the size of a city bus in a week? There's just the scale of all this stuff is so much more manageable and predictable.
This technology already exists?
If we are talking about Thorcon, yes, it has existed for about 5 to 6 years in Tennessee.
Oh, yeah. The molten salt reactor technology has existed since the 60s. It's being taken off the shelf and dusted off by Thorcon and Terrestrial Power in Canada, and 700 PhDs in China with $3 billion backing them up.
Yeah.
Proof of concept exists. That was established at Oak Ridge National Laboratory in the 1960s and 70s.
Exactly.
Utilization has not yet occurred.
Yeah. Now, and regarding the salt modular reactors, they are basically small, self-contained Generation 3 concept where it is a solid fuel, water-cooled reactor, but the water is inside the reactor vessel that runs by natural convection, as distinct from an external source of cooling water like Fukushima, where you better hope that thing works. And so a small modular reactor having a smaller core, it can keep itself cool with internal water, irrespective of what's happening outside the vessel.
In fact, a paper just came out saying that the NuScale reactor concept can cool itself without electricity or water, for that matter. Initial decay heat will be cooled off by evaporating water, and after that, all you need is a convective circulation of air to keep it cool enough so it won't melt down. So,
what he means by the evaporating water is you put the reactor in or near a pool, and an immediate shutdown. The first 3 days of shutdown is where most of the heat occurs. That's the meltdown danger. And these reactors are small enough where they have a swimming pool of water, and they just sort of like bubble away that water, and that cools them down, rather than pumping in 30 tons of water per second from the ocean.
It seems that nuclear is not competitive with natural gas at this point in time, and that renewables are making it even less competitive. How do you see nuclear breaking out of that?
It is absolutely true. a gas plant could be built for a quarter of the cost of even the most efficient reactors we can make these days. That is absolutely true. The thing is it's a finite fuel. Our proven reserves of natural gas in America are going to run out by about mid-century. And it's going to be even shorter if and when we start exporting the stuff, because people will pay more for it overseas than they will be here. So our gas farmers will export their product, which means we're going to run out even faster. And so if you have a gas-dependent grid, that's just a short-term solution.
If we accept the gas fracking industry's estimates of ultimately recoverable reserves in the U.S., we're not going to run out by mid-century. We are going to run out within 70 to 80 years if they're right, that we can get all that gas out of the ground, which, of course, we can't trust them on that. But it's a little bold statement to say we're going to run out by mid-century. They think if their reserves estimates are correct, at current usage, we can go for another 70 to 80 years.
Yeah, but if we start exporting the stuff, it's going to shorten that time scale.
Right, for sure.
If you follow Jacobson's path and you rely on natural gas as what we call training wheels to get the bits and pieces of it working until it all starts supporting itself, that's going to take until mid-century. And by then, we're going to be really close to running out.
Here's another consideration. I've recently discovered this academic paper called Nuclear Power Learning and Deployment Rates, Disruption and Global Benefits Foregone. I've got it right in front of me right now. And the question was, what would be necessary to reverse this negative learning curve of nuclear? And this guy, Peter Lang, has laid it out pretty concise. He says, well, we need to recognize that the disruption has occurred and that it is an impediment to progress. And secondly, we need to recognize the consequences of this disruption, meaning that it has literally cost lives and made people more sick. And third, we need to define the root cause of the disruption. And fourth, we need to implement policies so that we can remove the impediments so that the positive learning curve of nuclear can be picked up again.
Well, the disruption you're meaning is what?
So nuclear had a very positive learning curve from the 1960s up to the 1970s. And after that, the learning curve stopped because of disruption from whatever happened. So the point is, he has set out to prove that nuclear isn't inherently expensive, but that it has become expensive because of our response to certain events. Mm-hmm. It doesn't need to remain that expensive. We have learned from what has happened, must now take these things that we have learned and place them into the correct context and open up the pathway to a positive learning curve again.
Ed File from Elysium made a very interesting comment about switching to Gen 4 reactors. The point being that if you switch to Gen 4, there's a new set of regulations that would be put in place because there's all new standards. Therefore, we don't have to worry about the ratcheting of overregulation that's taken place over the last few decades.
I think that the concept with which he is working might become one of the final iterations of the nuclear reactor.
The fast reactor?
Right. Yeah, the molten chloride fast reactor.
Isn't that amazing? He wants to use frickin' table salt.
Yeah, and stainless steel for a reactor vessel.
Yeah, sodium chloride, freaking table salt, and 316 stainless steel.
What's also interesting is that his reactor runs at half the temperature.
It might be half the temperature, but the regulatory pathway is a lot easier, existing material, blah, blah, blah. And also the reactor he wants to design will eat nuclear waste or weapon material.
The failure of 100% renewable is becoming more and more obvious. How long do you think it will be before the general public recognizes this?
I think it will help tremendously when Germany starts to announce that they are effectively throwing in the towel, that they tried it, energy wind, they gave it their best shot. If anybody can do it, they can. They're geographically small, technically expert, socially cohesive, and if they can't make it work, probably nobody can.
Well, they did just this week. 2020 emissions target, there it is. Germany is set to abandon 2020 climate target. It's from Climate Change News.
Thies, I got a question for you concerning what you're talking about. Tell me if I'm right about this. Is that more right and center-right parties are gaining more strength? And it would seem that perhaps Energy Wende is already in trouble. I mean, I know in the United States, it goes on party lines.
Yeah, that's not so much in Europe. I don't think that it is going to happen that fast.
Polls for Energy Wende have not been going down, in spite of all the very expensive price of electricity and the problems they've been having.
They still think that the energy transition is good, and they still support the fact that they closed down nuclear because that was one of their objectives. I don't know, perhaps they are cognitively close to what is actually going on.
Yeah. I have to wonder if they ever get hit by the polar vortex and the only thing that's working is nuclear power, and God forbid that's all they got is windmills and coal plants. Oof.
Yeah. We are so far up north that solar radiation simply isn't sufficient. The claims that people make, they're grossly exaggerated. Listen, it's quite simple. I am on the hotline with an institution called Fraunhofer, and Fraunhofer basically collects all the energy data from Germany. Recently, I got all the data, so I created the graphs myself, and they have a total of 60 gigawatts of capacity short at this
They're
moment.
making that up with lignite, right?
They use lignite as base load, and they use hard coal as the offset.
Quite frankly, I think that nuclear fear is really the thing that's undergirding all of this craziness. Nobody would be taking this Jacobson crap seriously if there wasn't people having issues of radiation and contamination.
Yeah.
If the only thing the reactors did was spill hot chocolate sauce if they had a meltdown, you wouldn't see one wind turbine or solar panel in the country.
Let me say one thing, too, about that. I remember duck and cover. I mean, considering the Cold War and what my generation has been through, it's become an elemental fear that you could explain how safe it is very rationally. And after all of that, the person still has the gut feeling. No matter what you say, that fear remains. So
the book that goes into that better than anyone I've ever found is Spencer Weir's book, Nuclear Fear.
Yeah, I don't know if that's true the next generation. I hope not.
Well, see, that's the thing. I have young people that I talk to are very open to nuclear energy. And the only people I've run into that have a big problem with it are people my age. And actually what they're protesting is the conflation of nuclear energy and nuclear war.
Exactly.
Mm-hmm.
You don't need a reactor to make a bomb.
That's childishly easy. You need an accelerator.
You need a centrifuge.
You can use a centrifuge, or you can use a spallation source. There are so many ways you can create fissile material. The nuclear reactor is actually one of the hardest ways to do it, actually.
Particularly a power reactor. It's like using a locomotive to crack walnuts.
I have a suggestion that you guys, all three of you, should take your books and translate them into German and possibly other languages.
Mm-hmm. Yeah, we'll get a few things to our book. We're going to get a little bit more into explaining how the reactors work and tackling the issue of nuclear fear.
Well, that sounds great. Well, all I got to say to you guys is keep up the good work. We want to thank Thies Beckers and Mike Conley and Tim Maloney for being on this show. Thank you so much, fellas.
Yeah.
Thanks.
It was a pleasure.
And now for our final thoughts.
The scientific method is something that has long been considered a hallmark of Western thought and the reason behind the West having advanced so quickly technologically. Eco-modernists realize that the success of civilization will depend on these advances. But we have all witnessed what happens when the scientific method is ignored and claims go unchallenged. In the 1940s, the linear no-threshold model was established, which assumed that there is no safe dose of radiation at any level. Failure to decisively challenge this assumption has led to all sorts of consequences that are bad public policy. The 100% renewable myth is one of those consequences that must not go unchallenged. And that's it for our show today. If you have any comments, criticisms, or suggestions, feel free to email us at ecomodernistpodcast@gmail.com.
This is Gabe Ignetti.
And this is Rick Maltese.
We'll be seeing you till next time.